Hello, hi, welcome to another video. Today we are going to discuss about the selection of transformer for an electrical system. Before going into the selection of rating for a transformer, we need to select the desired supply voltage levels. In order to find out the supply voltage, we need to arrive at the connected load of our electrical system. The supply voltage for the electrical system should be selected based on the table given here. This is the clause number 8 of the Kerala State Electricity Supply Code 2014. Based on the electricity supply code, it can be seen that for loads up to 5 kW, only single phase 240 volt supply is required. And for the loads up to 100 kVA, 3 phase 415 volt supply is required. And for those loads above 100 kVA and up to 3000 kVA contract demand, 11 kV supply is required. Now, in order to explain the selection of supply voltage and the selection of transformer rating, I am considering an electrical system with the following loads. I have considered lighting loads to be 130 kW, power load to be 390 kW, and motor loads of 200 HP 1 number, 150 HP 1 number, 20 HP 4 numbers, 10 HP 12 numbers, 5 HP 15 numbers, and 3 HP 10 numbers are considered. And now coming to the total electrical connected load, the lighting loads are 130 kW, power loads are 390 kW, and the motor load is 488.03 kW. This I will be explaining later. So our total connected load will be 1009.03 kW, which means that our contract demand will be falling in between 100 and 3000 kVA. Based on the electricity supply code, we will be selecting the 11 kV supply voltage. And now we are going to see the methods of selection of rating for a transformer. The required kVA value of the transformer is chosen as the higher value of kVA, which are arrived from two different methods. Now we can see the two different methods. In method 1, the transformer kVA is calculated by considering the maximum demand of the system. Coming to the second system, the kVA rating is calculated by considering the kVA required during the starting of the highest rated motor in the electrical system plus the kVA required for the balanced electrical loads. Coming to the first system, we are going to select the rating of the transformer using the maximum demand of the system. Now we are going to see the steps involved in this method. In this method, we are calculating the kilowatt of all the motor loads, and from that kilowatt, we will be calculating the total kilowatt of the system. With the total kilowatt of the system, we can find out the kVA rating of the transformer required by applying the percentage loading of the transformer. And now coming to our example, the total motor load in HP will be 655, and it is converted to kilowatt by multiplying with 0.746, which will be giving the value of 488.63 kilowatt. In order to arrive at the maximum demand value, we have considered the diversity factor for the motor loads to be 1.5, and which will be giving the value of maximum demand as 325.75 for the motor loads. Coming to the lighting and power loads, the lighting load is 130 kilowatt and the power load is 390 kilowatt. The total lighting load and the power load is 520 kilowatt. We are considering the diversity factor of lighting and power loads to be 2. So the maximum demand of the lighting and power load will be 260 kilowatt. The maximum demand of the system will be the sum of maximum demand of the motor load and the maximum demand of the lighting and power load, which will be giving the value of 587.75 kilowatt. Now we are selecting the transformer rating by applying a percentage loading of 70% in consideration with the provision for future expansion. So after the calculations, the kVA required is arrived as 839.57 kVA. The nearest standard rating of the transformer is 1000 kVA, and so we are choosing 1000 kVA. Now we are going to see the selection of transformer using the second method. In this method, transformer rating is selected in consideration with the highest rated motor in the electrical system. The steps followed in this method are, we will be calculating the kW rating of the highest rated motor, and from this kW value, we will be calculating the kVA required for that motor during its starting. With these values, we will be calculating the kW and the kVA of the total system, and from that value, we will be arriving at the kVA required for the transformer by applying the percentage loading of the transformer. In our system, the highest rated motor is 200 HP, and the value in kilowatt is 149.2 kilowatts. The rated current of the motor is arrived as 149.2 into 1000 divided by 1.732 into 415 into 0.95, where 0.95 is the power factor of the system, which will be giving the value of 218.5 ampere. We are assuming that a star delta starter is used for starting this motor. So the initial inrush current will be approximately 2.5 times the rated current. Now we can calculate the kVA required during the starting as root 3 VA, which is same as 1.732 into 415 into 2.5 into 2185 divided by 1000, which is same as 392.63 kVA. Now we can calculate the kVA for the balance loads. Light and power loads as seen earlier, it will be coming to 520 kilowatt, and the balance motor loads other than the 200 HP motor will be coming to 455 HP, that is 339.43 kilowatt. Considering a diversity factor of 2 for the lighting and power loads and 1.5 for the motor loads, the maximum demand in kilowatt will be 520 divided by 2 plus 339.43 divided by 1.5, which is same as 486.26 kilowatt. Considering a power factor of 0.95, the kVA required will be 511.85 kVA. Coming to the total kVA required for the system, the total kVA required for the system will be the sum of the kVA required for the highest motor plus the kVA required for the balance load, which will be coming to 904.48 kVA. While finalizing the transformer, we need to consider the provision for future expansion also. So we are applying a percentage loading of 70% on the transformer, and which will be giving a value of 1292.11 kVA. The transformer capacity near to that rating will be 1500 kVA. While analyzing the two methods, we have seen that in the first method, the transformer rating was arrived to be 1000 kVA, and that in the second case was 1500 kVA. So we need to go ahead with 1500 kVA. In order to maintain the redundancy of the system, we shall choose two number of 750 kVA transformers. This was all about the selection of supply voltage and the selection of transformer rating. In the next video, I will be discussing the rest of the parameters related to a transformer. Hope the video was informative, and if you liked the video, please like and subscribe my channel for more informative videos. Thank you for watching the video. Thank you.